Welcome friends to my YouTube channel for yet another video on generative AI using LangChain. So in my previous video, if you remember, I have talked about, LangChain tools. And today in this video, we are going to talk about the LangChain tool, but this time we'll be, roaming around to the section of the custom tool. So you may be wondering, why I'm dissecting, this kind of small video and targeting each and individual portion of the LangChain in this way. Okay, if you ask me that question, the primary answer is behind that. If you search on, internet, so many material on LangChain generative AI will be available to you. But the primary thing is that what I believe is when you are trying to learn a particular thing, a new thing, then it should not be on a superficial way. Okay, some in-depth knowledge is necessary to go further, because working around 20 years of, more than 20 years in this industry, what I have learned, the deep knowledge will help you eventually to work on the real-time use cases or real-time problem solving in the industry. So that's my objective actually. So today we are going to discuss a deep dive into the domain of LangChain custom tool. So without further delay, let's kick off. So first of all, custom tool. So custom tool is something like that, LangChain has so many tools to be offered to the end user that can be facilitated, that can be used to on different problem solving or use case solving cases. But there are certain things that cannot be handled by any out of box tool that being offered by LangChain. Rather, to solve a specific business use case, because your use case should be very much tightly aligned or coupled to the problem that you are handling right now. Okay, so obviously at that point you need to make your own tool to resolve that out. Okay, so there are actually in LangChain there are 4 ways you can create your custom tools. So you may be wondering, why I need to learn the 4 ways. One or two should be enough, right? Why to learn 4 ways? Okay, because the reason behind it is that how I've written this article, it's like that I have said way 1, way 2, way 3 and way 4. Okay, so way 1 is the most easy, it's just mere 2 or 3 lines and you are ready with your custom tool, but it has a less flexibility. And going downwards, when we touch on the way 4, you will see that way 3 and way 4 are a little bit critical to write. It will take some time to write up the tools, but you will have much more granular flexibility on behavior of the tool. So it's a kind of simple versus critical, or you say simple or the facility of the particular tool. Okay, it's an inverse ratio. So let's start with the very simple thing first. So this is the way 1, how you are going to create your custom tool. So this is very only 3 lines. Frankly, if you count over here, it's only 3 lines. Okay, and I have copied this particular line from LangChain site itself, and I have obviously provided a link to you for further study also. Okay, so using the @tool decorator. So if you are coming from any kind of programming language, you should be knowing what is a decorator all about. Okay, so I'm not discussing about what decorator is. Okay, it's a pattern, you should be familiar with that. Okay, so now here what exactly we are going to do is that we need a let me go over here. Okay, first of all we need to import one particular lib. Okay, so that is here, you see, from langchain.tools import tools. Okay, that is the line that you need to import first. Okay, because this decorator that we are going to use @tool is available under this lib. Okay, so that is why we try to import it first. Now It's very simple. It's written over here. It's described as, just define the function, your custom function to cater one particular custom business scenario. Okay, now after writing the function, you just execute whether the function is working properly or not. And if you are satisfied that your function is working properly, then only one tweak you need to apply is that particular decorator @tool. When you apply this particular decorator @tool at the top of this particular function, it become immediately a LangChain custom tool. Okay, that is very easy and fast process. So as you see, my function is very simple. Actually, it is taking two integers a and b and returning, after multiplying two numbers, it is returning the resultant to us. Okay, so it's a cross b. So and return type is obviously the integer. Now here, if you read this lines, it says that this @tool decorator is a simple way to define custom tool. It's very simple. You just need to apply the @custom decorator. That's it. Okay. The decorator use the function name as the tool name. So you may be wondering, if this is my function name, what should be my tool name? Okay, so if you do not specify anything over here, as you see this def of this function, okay, it is clearly written that the first argument is a str type of argument, and it can be accepted by this decorator, and it is the name of the tool. Means if you don't pass it, then whatever the name of your function, it become your tool name. Okay, so for this particular example, now I am not passing anything over it. Okay, so let me just execute it. So this line has been executed. Now see one particular thing. Now I want to see that it is a function, right? FNC, if it is not decorated by the tool decorator, then obviously in Python FNC underscore multiply is a simple function. Okay, but as we applied this particular @decorator tool over here, let's see what the type has become. Okay, so see, now this FNC multiply is not a function anymore. Okay, when we apply @decorator tool over here, it immediately become a structural tool. Okay, in LangChain core tool structural tool. So that means this particular decorator has converted this function to a structured tool in LangChain. Okay, clear enough? I hope so. Now every tool, remember, every tool has three things. Okay, one is the name of the tool, one is the description of the tool, and the third is obviously the arguments that we want to pass to the tool or the function, right? Here one particular important factor is that, if you remember, when we are discussing about in previous video, when we are discussing about the inbuilt tools, we have told couple of times that this particular description is very important for the tool, so that by the description actually the agent understand resolving what functional scenario, which available tool from the tool bucket it is going to pick up. Okay, so if you see this doc string over here is the description of this particular tool. So where we are stating that simple description, multiply two numbers, that is for the description part. Okay, and the argument is here. So if I want to print out these things, you will see that the name of this tool has become FNC multiply, as we did not supply any explicit name at the tool decorator. That we will do eventually. Okay, now description, as you see, is the description, multiple two numbers, and the args are printed over here. Okay, now, but in some cases, okay, you may want to a different name of the tool, which is different from your actual function. Okay, a slight curve or the division points. So here you see the same logic applies over here, and if you compare with the previous, only the difference is that now when we are doing the declaration, okay, we are using one particular name for the tool. Okay, so function has a different name. Now the tool has a different name altogether. But previously it was the same. As we you have not passed any kind of naming in the previous section. Okay, so it's a similar approach that I have written over here. It's a similar approach, but this time we are giving a name to the tool. Okay, so that our function name and our tool name are separate right now. Okay, so let's run this thing, then we'll understand more. Now I am doing the same print statement. As you see, now if I, this is my tool, and if I ask for the name, it is showing that multiply. It is not FNC multiply. But in the previous example, it was showing FNC multiply because in the previous section we had not supplied any kind of name at the time of decorating the tool with the @tool decorative. Okay, so now we are passing the name, so the tool name has become multiply, although the remaining or the underlying function name is same as FNC multiply. Hope this explanation for this section, the way one, is very much clear to you. Okay, so as I told you, this is the fastest way. When you have a function with you that you want to convert in LangChain tool and just want to readily use it, you should be following this. You do not have much control of the behavior of the tool, but still it's a very fast process. So at the time of doing some kind of demo or your demo work or some kind of experimental work, you can just sprang that out. Okay, now we are going for the second way. So here, if I expand this section to you, what is happening in the way 2? Now we are splitting the function at the tool. Okay, what does it mean? It means that in the previous example, if you see, I have decorated this function with the decorator @tool. I have supplied a different name to the tool, but this section is pretty much tightly coupled up. Okay, but there could be scenario where you want to create your function first, then create your tool separately. The advantage of this way 2 is that, see, this is your function, right? Def FNC multiply. Now let's assume that you are how to, first of all, let's understand how we are creating the tool which is separate from your function. Okay, so the function is pretty much clear. It is the same function. I am not changing the signature or the description. A slight description change is A times to B. Okay, it's a multiplication, same. Okay, now here is your function, and you see here is your tool. Now the fantastic part for this approach is that, as you see, you are creating this tool. Okay, so you are creating this tool, you are using the name of the tool which you want to give, and you are mentioning the function, the underlying function for the tool. Now this section and this section is very much separate. Okay, so the advantage is that now you see for your demo purpose, let's say you have created one particular function. Okay, and you are expecting some kind of behavior out of that, right? But in real time, you see that is not yielding up the expected result. So you may need to write another function to cater the same thing, or you maybe needed to fine tune your function and writing down another function. Okay, so you no longer need to change your tool. Means, see, the thing is that if you come if you just want to visualize, if you're let me see whether I can bring up the thing to you. So I will try to explain you more clearly what I'm doing over here. You see, if you remember when we discussed about the tool, about this section, so if you remember that this is our inbuilt tool that we want to inject to the pipeline when the agent communicate to the LLM, right? Now your custom tool will be here and it should be injected to the pipeline the similar way as we do in the inbuilt tool. Okay, now let's say that when we talked about the inject, okay, so if you remember in the previous video that when we want to associate our tool with a particular agent, so the process is that you create your own function, okay, then you create the tool out of that, then associate the tool with the agent. Now let's assume that you have done all the things, but your certain expectation from the tool and the function was not meeting up. So you no longer want to disassociate the agent with the tool, rather in the tool you want to change the function. So if you are working in the way to, then it is become very easy, because if your tool is not performing well, you just need to change your underlying function. Okay, so now I'm working with FNC multiply. Let's say that it is not yielding up the expected result, then it can be FNC something, right? So I no longer need to disassociate my tool from the agent, rather I should be disassociating the function from the tool. Okay, so that's the concept of way to, and why and where it will help you. Okay, I'm trying to explain you. See, learning is a separate thing, and apply the learning in the real time scenario is a very different thing. Okay, so I'm trying to help you that where there are 4 ways to define a tool, right? So which way you are going to pick up to address what scenario, what real time problem, right? Okay, so let's run our way to over here. So it has created the tool for us, and if you print, and you expect the behavior, and that should be the same, all whatever behavior that we are expecting over here, that this is the name of the tool, this is the function that identity function is calling, and this is the description of the tool, and it is written over here. Okay, one thing to watch out over here, a little bit carefulness is needed. You see, function has a different description, but tool has a very different description. Okay, it's not different, but what I mean to say, the sentence here, multiply a times to b, okay, and here use this tool to multiply a times to b. Okay, so use this tool was being added. Now when you type to print the description, you see the description is picked up from the tool, not from the function. Okay, just remember these points. Fine, so way 2 is being covered for us. Now let us go a little bit critical example where we are going to do some coding. Okay, the code length will be a little bit longer, but it will give you much more control over the situation. Okay, so way 3 we talked about. Now in the way 3 we are going to talk about the creation of the tool, which will come from the subclass base tool. If I expand this section, and it is clearly written over here, is that now we are creating our tool deriving from the subclass base tool. Okay, you can also explicitly define a custom tool by subclassing the base tool class. Okay, this provides maximum control over the tool definition, but a little bit of more work. So base tool, where you can find it, it is in the langchain.tools. From langchain.tools you can find the base tool. Okay, so here exactly, and what we are going to do is that we are creating a class. Okay, so from way 1, if you remember, from way 1 to way 2, we are not defining any kind of class, right? We are only creating function, and we are trying to create the tool out of that. That was the association between the function and the tool. Now in this particular example, in the way 3, actually we are creating our class. Okay, multiply is our class. Okay, and which is deriving from the base tool class. Now you specify in the name, okay, and the description of the class, means the tool will be coming out of this particular class. Okay, so the name and the description what we are putting over here, that will be used at the time of creating the tool from this particular function, class. Okay, and now you see you have a little bit of control, means def run. Okay, so def run and a run, it's an asynchronous expression, so I am not working with async right now. We can discuss on later videos, but for now I am only focusing on the sync functions, synchronization functions. Now you see this is run function. Okay, and actually what will happen under the scene is that it accept, as you see, it accept two parameters, so it's x and y, and x and y, now it's a union of int and float, means int can be first passed in, or float can be passed in also, and return behavior is a float type, and it will do the same thing like multiplying the two inputs. But here you see one particular thing is that now we have much more control over the tool. Okay, when we create a tool out of this, which I will be showing over here, how we are creating that, then when we execute the tool in the agent, whatever written in this run function will be invoked by the agent. Okay, that is the significance of this particular run method over here. Okay, hope this explanation clears everything, how to create a tool deriving from the base tool. Okay, so we are not creating a tool directly, rather we are creating a class. We can use the class to yield up our desired tool. Now in this example you will see that how we are gaining more control into it in the situation, as I told you in my beginning of the video. So as we move down from 1 2 3, in this way, it will become it will need a little bit of coding to do the things as we gradually progresses, but it will give you the maximum control over the behavior of the tool. Okay, now you see how we are getting the behavior out of it. Okay, previously this input has no validation. Okay, means here the input has no validation. You see in the function it has no validation. Now what is happening over here is that this is our, if you remember, this is our multiply class. Okay, that is deriving from the base tool, right? And it accept two parameters in a run function. You see the x and y. Now we are defining here what is actually x and y, so putting some kind of validation around the pass value to x and y. Okay, and the description also for the x and y. Okay, so how we are achieving that? Here we are creating a very separate class. Okay, that called multiply input, and it also derived from the base model. So our class multiply is deriving from the base tool, and our input to that particular function x and y are coming from the base model. From where you will get the base model? It is langchain python underscore v1. You will get the base model from here. Okay, so here we define what is x, it's an int, and what is the description of x, that is the first number. Y is the second number. Okay, we are giving some kind of description to the input values. Now when we create, obviously when we call this particular class, what is the expected behavior? Okay, that will give us the input parameter to be passed on this particular class or the tool. So in the R schema, as you see, we are giving type as a base model, casting to the base model, because multiply input, which is our target, is deriving from the base model. So obviously a derived thing can be casted back to the base, right? That's the concept of oops. So now here we are doing the same thing. So arg schema is the argument. If you remember, when we are discussing on the tool, that I told you there are three factors in a tool. One is the name here, one is the description here, and the third one is the argument of the particular function or the tool, right? So that's arg schema. Now we are saying that this particular class in the run function, it accepts the arguments, okay, which is of the type multiply input, okay, and the rest goes the same way. I hope this is pretty much clear to everyone, right? Remember, this R schema is nearly have to be equal with the run inputs, whatever the run is expecting over here, okay. And we also can, as I told you, you can have much more control over the behavior of the tool, okay. And you see, if I touch over here, you see self, x, y, and the callback manager, means you can assign a callback manager to this particular function also, okay. So if you want to call back one particular function or sort of code by a callback manager, when the tool is being invoked, you can inject that also over here, okay. So you are getting more and more control in the tool. For now, I am saying that my callback manager is none. I have not set it any kind of callback manager for this particular example, but it can be. That's the point to be discussed over here. Fine. So let's I'm going to run it, this one also and this one also, okay. Fine, fantastic. So as you see, our class name is this. So obviously, if you so as you see, the name is multiply. Use this tool to multiply two numbers, okay. This is the description of the tool here, okay. And the input, see the the input, look at the input very carefully, okay. So as I told you that this is the description of x, first number, this is a description of y, second number. So if you look at this description section, you will see that it is taking the description of the args from where the argument has been created, okay. So that is the base model multiply input, where we specify what is the description of x and y, okay. And here we create the multiply input as and assign back to arg schema. That's the objective over here, okay. And you see it is coming on the description section of x and y, what we have been jotting down or writing down over here, okay. So now we have our tool to be used. So this is the third example, creating a tool deriving from the subclass base tool. Now the fourth way. So in the fourth way, it's a mix of you can say that you can put one or two one side and approach three another side, okay. One or two less critical, less control, three more critical, more control, and the four is it's a midpoint of simple versus critical, okay. It's neither simple neither critical, it's a midway of simple and critical. That's a number 4 way, okay. The fourth way that we are going to discuss right now. Here what you can do is that, if you remember, when we show the example in number 1, when we are creating the tool, okay, and when we type to type of the tool, we are interested about the type of the tool, okay, that is structured tool, LangChain core tool structured tool, okay. Now, so obviously every tool in LangChain is becoming a structured tool, okay. Now in the fourth, where we are doing exactly, we are creating our tool by invoking one function under the structured tool, okay. So you see the function name is structured tool.from function, and if you read the signature of the function, it says that it create a tool from a given function. Okay, so what does it mean? It means that, let's say that you have a function, right? But you don't want to deal with the tool section at all. You are not interested. Okay, so but you want a structured tool to be back to you. Okay, so this is the way to go on. Means you can directly call a function in structured tool. The function name is from function, and give the function name. If you see the signature, it expecting a function name to be here, that it will invoke and create the tool back to you. Okay, name of the tool and the description of the tool. So function, we are using our function name, we are providing over here, and this is a description of the particular tool. Okay, so it means that when we invoke this particular function from structured tool dot from function, we pass a function, a targeted function that the tool will use at the time of execution, and the name and the description. The tool will be created out of the box for us. Okay, so multiply tool has been created over here. So this is the way forth. So where you can find the structured tool class, you will find that under LangChain tools. Okay, LangChain tools, import, base tool, structured tool and tools, all the things are under LangChain tools. Remember these things. Okay, so this is the fourth way. So now, so let's run it first. Okay, now it is returning back to us. I hope this explanation of the 4 ways is pretty much clear to you. If you have any question, please let me know in the comment section. Only one thing I want to focus over here, on a simple thing. Now when you type the description, okay, you see and the args also. Okay, it's a bit interesting. If you remember in the argument section, it's like that a title a, okay, type integer. But if you compare the way 3 over here, the same output. Okay, so you will see, I'm just trying to show you side by side. Let me squeeze it down. Okay, 1 minute, hold on. Fine. You see, here is a description which is coming from number 3. You see what has been, the description. Look at the description. First number and the y is the second number. Okay, remember in the third step, right? When we declared, our string from the class. Okay, and we created our arguments over here. First number, second number as a description of this argument. So when I printed the thing, it is saying that description is the first number and second number. But if I don't go in this route, okay, then in number 4, see the description difference. It is a title, title A, type integer. But under description, it has provided nothing, because I was not passing any kind of description. I was coming from this particular structure tool from function. Okay, but here I am doing a little bit of coding, and also I am writing what is the description of the arguments also. That is why it is printing and coming over here. Okay, and that will help your LLM, your agent to understand the tool more. Okay, that is the purpose of it actually. Now, so far, we have covered this, section 1, 2, 3, 4 for creating, the custom tool in 4 ways, 1, 2, 3 and 4, right? Okay, fine. Now we'll see, how calling a particular statement to LLM give us a same output, but how we can invoke this custom tool with the agent to execute the tool instead of giving the LLM giving the direct answer back to us. Okay, sorry. Now if you remember, Now we are creating the comparison between the direct LLM call and the agent call. Okay, here it's simple that we are creating our chat OpenAI, our LLM model over here, and obviously when you will be taking the code, all the code are available in the Git, and the Git link is given already, should be given in the description of the video. Okay, I will give that. So only one thing you need to change is that I am using my OpenAI key. By using this particular function, it is returning back me the OpenAI key rather. Okay, but when you are working, definitely you should be replacing this portion with your OpenAI key, that what I am written over here, put your OpenAI key over here. Okay, so let me execute it. So now this time I am asking the large language model a direct question, multiply 2 and 3. Okay, so no agent is being integrated to this section. It's a direct call, direct prompt I am passing to the large language model. So this is the response. So we expect, right, it should be able to calculate 2 into 3. I'm just giving you a demo use case. Okay, the main interesting thing is how can I force the LLM to use my tool. Okay, the custom tool, rather giving the result out of box. Okay, that's the purpose of it. So here it's a direct call and it is giving 2 into 3 as 6 expected behavior. Okay, and you see it is using GTP 3.5 turbo I am using for this particular example model name. Okay, now what exactly we are going to do, that if you remember this diagram, using this inbuilt tool or custom tool, you have to pass, or we have to pass by the agent, because we supplied the tool not to the LLM, we supplied the tool to the agent. Okay, the agent is the decision maker, it's an autonomous body who makes a decision, who took a decision to communicate with the LLM and use the tool. Okay, so agent is the main brain center. Now here we are creating our agent. So in this case, so agent has different types, and we are dealing with the tool calling agent type this time. And in our next video, subsequent video, when we will be talking about the agent and agent type, we will be discussing more, because that will be a longer discussion point. Different agent type expect a different prompt and execute a different behavior. Okay, so that's a very separate topic, we'll discuss on another video, upcoming videos. Okay, but here in a simple way, just understand we are creating a tool calling agent over here. Okay, and we are taking from langchain.agents, and we are also taking the agent executor class. Okay, agent executor will create the agent, execute that. Okay, create the behavior of the agent. Okay, now here this it's a list. Okay, list of tool. So if you remember, we have created this multiply tool over here, over our top section, and we are just passing this as a we are just pushing this particular thing in an array. Okay, or list of tools, and we are associating here, because we are creating the tool call agent, but if you use a different tool, this portion will be a little bit different. Okay, so we'll be discuss on the agent video definitely for this section. Now LLM.bind tool. Okay, we are supplying the tool over here. Okay, prompt, when we work with the agent, we'll be using the prompt. So I am creating the prompt from chat prompt template from message, and you see it has a system human and placeholder. Okay, why it is like this, how can I remember this? If you are asking this kind of, if you are getting this kind of question on your mind, it's not surprising. Okay, it's really valid, because we cannot remember everything. So how to do that? On the agent video, I will give you more explanation onto the prompt, how a particular agent type is associated with a particular prompt and how it behaves with the prompts. Okay, for now just understood, this is a system message, It's a human message and this is a placeholder. Okay, why prompt is necessary? Prompt, actually agent use this prompt to pass to the large language model. Okay, prompt is the instruction that we send to the LLMs. Okay, so that LLM can read the prompt, understand what is given, what is the expected behavior from the from the LLM, and it will execute on the same way. So here human give the input. Obviously we will be asking the large language model one particular question, so that is our input section or input parameter. Okay, and what is agent scratchpad, we can discuss on agent scratchpad more, but for now let understand agent scratchpad is a placeholder where agent need a space to think. Okay, that is his scratchpad. Funny name, right? Agent scratchpad. Anyway, so now here in this particular line we are executing create tool calling agent, and we are passing it. If you touch over here you will see that it is getting few parameters. One is the large language model, what we are going to use, what tool we are going to pass, and what is the prompt. So we are passing 3 variables over here, and we use the agent executor to get the executor out of it. Okay, and we are making verbose equal to true because we want to see the how the agent is thinking and the process is going on, something like that. Okay, so now you see in the input, you remember the input, right? So this is the input to input. Okay, and this is the query that we are going to ask to the LLM via agent. So let us execute these things. So see, entering a new agent executor chain. Okay, invoking, see, he's invoking this tool because I have passed this tool to it. Okay, and it is using it and return the result back to us. Okay, so we are successfully invoking or forcing our agent to use the particular tool when it's tried to communicate with the LLM. That was the purpose of creating the custom tool. So it's a very simple multiplication tool. For different use cases we can create more tools. In the upcoming days we will be doing that to handle different critical business cases over here. Okay, so this is how we create a custom tool. We associate it with a particular agent and we invoke a chain of thoughts for the agent. Okay, pretty cool, right? Yep. And here is another small portion that I have written for you. If you want to be just a simple use case, nothing fancy over here. So it's again a direct call to the LLM. Okay, so the query is create a Panda data frame for the following. Okay, so I am passing on a dictionary over here. Okay, so I'm asking it to give me a Panda data frame back from it. Okay, so if I execute this, you will see I'm executing directly to the LLM. Okay, and it is smart enough to cater our request and return back the data frame expected format. Okay, now I will do the same thing here by our own tool. Okay, now we are creating a list. So this is the list that we have passed, and invoking the LLM directly, it gives us a final data frame back. Okay, now in this example what exactly we are going to do, that we are creating our tool. Okay, and this is the function for the tool. You see the description, generate a Panda data frame from the list. So the input parameter is a type of list. Okay, we have instruction, our instruction is very clear to the function. Then I am writing that just to prove the statement that it is really executing this particular function. Okay, or not. That was just I want to prove that why I have put it a print statement over here. Okay, so it is taking the data and using the PD data frame, it is returning the data frame back to us. Okay, now here we use the structure tool from function. If you remember the number 4 path, so that is what it is. Okay, so let me create the tool for us. Okay, so the tool has been created. Okay, so the name of the tool is the FNC PDF from list tool. Okay, now here what exactly we are doing, here now here actually see, we are taking our this tool which we have created over here. Okay, in a list of tool, we are binding our tool to the LLM as previous. Look at the prompt. Okay, so it is the input, is the agent scratchpad. Okay, return only the final output to us. Now here we are doing the same activity that we have discussed before. Okay, and the same query has been passed, means it's a direct call to the LLM. If you remember, it is able to give us the panda data frame back. Now we are passing the same input over here also, but this time via agent and a custom tool. Okay, let us execute it. See, again the chain has been invoked, agent executor popped up, it's creating the agent. Now as the query said that we want to create a panda data frame out of this. Okay, it is going for this particular tool. Okay, with the data, this means it's the thought of the agent. Okay, and this is a print statement which we have printed just to make you this is a proof of evidence that it is really executing the function of the tool that we have wanted. Okay, so this is the output, and see the output is over here. Okay, now if you just take the return value, means the output section out of it, you will see the output is this one. Okay, and it's a data frame. This is a data frame. Actually, it's a line delimiter here, and if you just execute this small function, it will return back you the PD data frame out of this. Okay, so combining these two functions, top and this one, you can easily get the panda data frame back using our custom tool. Hope this total portion was very interesting to you, and I have tried to explain you 4 ways of creating a custom tool. If I again go to the top, 4 ways of creating the custom tool, and the difference between a direct LLM call and when we integrate our tool to an agent and pass the query via the agent. How the behavior, or it is we are forcing the agent to use the tool, not give the direct answer for the LLM. Okay, so hope my explanation to the custom tool world is good enough for you to understand. Just remember, one particular thing can be catered on many ways. Means if you are creating a custom tool, you can go in 4 ways. Okay, which one you need or which one depend upon your business cases is always a variable, varying thing that has a no fixed value in it. So I cannot tell you that use the way 1 or use the way 4. Rather, you have to understand your current problem statement, and you have to make a decision, how we are going to write the custom tool. Okay, but the end behavior is the same. We are going to integrate this tool to the agent. User will fire the query to the agent. Okay, agent is the brain. He will think what is the question, what kind of tool I have availability with me, can I use the tool to cater the particular query. Then the end thing will be passed to the LLM for fine tuning, and LLM will return the back. Okay, so agent, the responsibility of the agent is passing the context, means the query with some relevant information or the tools to the LLM, so that the LLM can respond back. Okay, so hope this explanation is good enough for you for the custom tool section. And if you really like the video, please give us a thumbs button. It will encourage me to make further videos and discuss with you. And again, I'm telling you, see, if you search on YouTube or anywhere, you can have many videos on LangChain, agent, large language model, generative AI. But my purpose is not going to directly to discuss all the things. I am just going for a very granular way. Okay, I am making every video for every small blocks of in the LangChain, because as I told you, working more than 20 years in this industry, what I have understand is that when you have a little bit of depth knowledge, it is always helpful to address the real-time business critical situations. That is why I am making this kind of video, to make you comfortable with the LangChain world. Hope we'll meet in the next time in the next video. For now, let's enjoy the video, give your feedbacks. I'll be happy to respond to you back, and I will share the code to the GitHub. The Git link will be associated with the description box of the video. Give a thumbs up, like, or share if you can, if you like. Also, if you want, you can subscribe to my YouTube channel so that we can have our journey together. Thank you.